In this video, we will learn how to describe acid-base titration methods and their use in determining acid and base concentrations. In this video, we're specifically going to be looking at acid-base titrations. So what's the purpose of an acid-base titration? When doing an acid-base titration, our main purpose is to work out the concentration of an acid or base which is currently at an unknown value. We do this by using an acid or base that we do know the concentration of. Of course, if our unknown solution is an acid, we want our known solution to be a base, and vice versa. So let's have a look at how to set this up. Here is an example setup of the equipment you'll need to carry out an acid-base titration. At the bottom, you'll need a conical flask. This is sometimes called an Erlenmeyer flask. The shape of this flask makes it ideal for swirling liquids. This is something you'll need to do during the titration. By using a conical flask to swirl your liquids, you're far less likely to splash anything out of the flask than if you were using something with a wide neck, like a beaker. You'll also need a burette. Burettes are good for accurate liquid measurements in instances where you don't know at first quite how much liquid you're going to need. Of course, if you know exactly how much liquid you need, you would use a pipette. You'll also need a retort stand, sometimes called a clamp stand. This has a heavy metal base and a metal pole that extends upwards. It's onto this pole that you can attach clamps with which to secure your burette. Of course, you don't want to make this too tight and risk damaging the glassware. When setting up your retort stand, you need to be careful about which orientation you have it in. You want to make sure that everything that you're clamping is overhanging the large part of the base. If you have it the wrong way round, you risk everything toppling over. This can be both dangerous and expensive. You may also decide to place a white tile directly beneath your conical flask. This can be helpful if you're looking for subtle colour changes. Now that we have our basic setup, we need to work out how to run this titration. Let's begin by looking at our two main solutions. Our two solutions are referred to as the titrant and the titrand. You may also hear the titrant referred to as the standard solution. This is the solution that we do know the concentration for. And this is the solution that we must place in our burette. On the other hand, our titrand might be referred to as the analyte. This is our solution which has an unknown concentration. And it's this solution which should go into your conical flask. Bear in mind that even though we aren't certain of the concentration of our titrand, we must use an exact known volume. This will be important for the calculations that you perform after you've done the experiment. We won't go into the calculations in this video. So how could you remember which goes where? You could remember that the unknown concentration is a known volume, and since you have to know the volume at the start, that must go in the conical flask. There's no point in using a burette to add an exactly known volume. Alternatively, you could remember that the titrant, ending in T, goes in the top, and the titrand, ending in D, goes down at the bottom. Once we've added both of our solutions to the correct glassware, it's time to add a few drops of indicator. We'll look at how to select the right indicator later on. We're now ready to run our titration. It's a good idea if your first run is very rough. So rather than adding your titrant dropwise right from the beginning, add it a few centimetres cubed at a time until you notice the indicator change. Once the indicator has changed colour and swirling it doesn't make it turn back, you've got a rough idea of how much titrant you need. Let's say that in this example it took about 40 millilitres before the indicator changed. Now we'll need to clean out our conical flask and refill everything. Our subsequent runs will now need to be much more careful. We can start our more accurate run by adding a bit less than in step 1. As an example, let's say we add about 35 millilitres. Next, we need to add the titrant a couple of drops at a time, making sure that we give our conical flask a good swirl. We continue adding a drop or two of our titrant at a time and swirling, and then adding a few more drops and swirling until our indicator reaches the end point. This means that the indicator is just turning whichever colour it's supposed to. Of course, you'll need to repeat this experiment several times to make sure that you're getting the right result. You want your results to be both accurate and precise. Now that we have a rough idea of how to carry out an acid-base titration, let's take a closer look at our titrant. Remember that the titrant is also called the standard solution. And this is the solution for which we know the exact concentration. So how do we make up a standard solution? Often it depends what type of solution you are preparing. It could be that you need to add an exact known mass of a solid to a volumetric flask and make it up exactly with your liquid. For example, you might need an exact mass of sodium hydroxide pellets and make it up to the line on your flask with water. Alternatively, it could be that you need to mix two liquids together. This might be the case, for example, if you need to prepare a hydrochloric acid solution. It could be that the hydrochloric acid you already have is too concentrated, so you need to mix it with some water to dilute it. Either way, the key points are that you have to know exactly how much of each substance you're putting into your standard solution. To measure exact masses, of course, you'll want to use a balance. To measure volume, you'll want a pipette or volumetric flask. However you make up your standard solution, make sure that you make plenty of it. You'll need to run your titration 4, maybe 5 times. So you'll need to have enough standard solution for all of these runs. You probably want a little bit extra as well, just in case. Preparing the titrand is much more straightforward. You simply add an aliquot of your titrand to the conical flask. Aliquot is simply the scientific way of saying a small sample. Remember that since your titrand has an unknown concentration, we must use a known volume. You could use something like a measuring cylinder, but a volumetric pipette is much more accurate. You could also use a graduated pipette. Now that we have our 2 main solutions ready, we should have a look at indicators. So why do we need an indicator for our acid-base titration? In this example, let's imagine that our titrant, that is the solution in the burette, is a base, and our titrand or analyte in the conical flask is an acid. Let's say that the starting pH of our acid is 4. As we add drops of base and swirl, our pH will start to increase. We're aiming to add just enough base that we neutralise our acid, leaving us at pH 7. As we get close to neutral, our indicator may start to just change colour, but as we swirl, the colour changes back. As we exactly neutralise the acid with our base, we would expect the colour to remain permanently, even when we swirl. And we just want a hint of colour change. This moment is our end point. If we were to carry on adding our titrant, the pH will continue to rise and the colour will become much darker. This means we've gone too far. If this happens, we'll have to start again. Indicators help us to recognise this end point. The indicator in this example is phenolphthalein. Phenolphthalein is colourless in acids, but turns pink in bases. So when using phenolphthalein as an indicator, you can recognise the end point because you have just a tiny hint of pink, which doesn't go away with swirling. Of course, if you're doing this the other way round, and your titrant is an acid, and your titrand is a base, what you're really looking for is for that lovely pink colour to have just disappeared completely. Another commonly used indicator is methyl orange. Methyl orange is red in an acid and yellow in a base. The endpoint for this indicator is when your solution is a hint of orange. The way that indicators work is that they themselves are actually weak acids or bases, and this is what helps them to change colour. There are of course many other indicators, but these are the two most common. It should also be noted that not all indicators change colour at pH 7, and you could also use a pH meter instead of using an indicator. We don't tend to use litmus paper or universal indicator for acid-base titrations. Using litmus paper is just too fiddly and not accurate enough. And universal indicator changes colours over a wide range of pHs, which is not very helpful for titrations. Now that we have a solid understanding of titrations, let's have a look at some of the things that might go wrong. The first potential source of problems in titration experiments is the equipment. Incorrect use of the equipment can cause your results to be incorrect. An inaccurate burette reading is a common problem, and there are lots of reasons that you might get an inaccurate reading. Imagine you need to read the value from this burette. Where do we take the reading from? Which of these is correct? The answer is the bottom one. You should always take your reading from the bottom of the meniscus. Other tips for always ensuring an accurate burette reading are: get rid of any bubbles, make sure that you always know your starting value before you run your titration. Usually this is at 0, but not always. Never start using your burette if the liquid is above 0 mils. And if you filled your burette with a funnel, always remove the funnel before beginning your experiment. This is because the end of the funnel can displace some of the liquid and thereby change your readings, or the funnel could contain extra drops of liquid which will also alter your readings. But what else could go wrong with the equipment? If you don't use an exact volume of titrand in your conical flask, that can also affect your results, as can incomplete mixing. If you end up with droplets of titrant stuck on the neck of the conical flask, this has been accounted for in your burette reading but has not mixed with your titrand. This means that your results will not be accurate. You can avoid these droplets by being careful how you use your burette and by ensuring that you give your titrand a good swirl. You also want to avoid droplets stuck to the end of the burette. If this happens, gently touch it onto the side of the conical flask and swirl it in. Muddling up the solutions is also a possibility with titrations. To avoid this, make sure everything is carefully labelled. This will hopefully stop you putting the wrong solution in the wrong piece of glassware. The indicator can also cause issues. For example, you might have chosen an indicator where it's really difficult to detect the colour change. An inappropriate indicator or simply not being careful with your experiment could mean that you miss your endpoint. There are also safety hazards associated with titrations. Doing these experiments means using acids and bases, many of which are harmful or corrosive. So care must be taken. You should always make sure that your equipment is secure and safe before you start your experiment. This will prevent your burette and all of your equipment from tipping over. You should also always fill your burette safely. This means never filling your burette above eye level. To do this, you could place your burette on a stool or on the floor. This prevents you from splashing potentially harmful chemicals onto your head, face, or into your eyes. You may also choose to use a funnel to fill your burette to avoid spillages. This is perfectly fine, but remember to remove the funnel before starting the experiment. Now let's have a look at some questions. A student wants to use titration to determine how much acid is needed to neutralise a known volume of base. They set up the experiment as shown. At the start of the experiment, which solution should go into the Erlenmeyer flask and which should be used to fill the burette? This question is asking about an acid-base titration. This type of experiment is used to determine an unknown concentration. The solution which fills the burette is called the titrant. You can remember that the T at the end of titrant could stand for top, meaning it goes in the top. The titrant has a known concentration and is sometimes referred to as the standard solution. Our titrand goes into the Erlenmeyer flask, sometimes called a conical flask. This is the solution with an unknown concentration, sometimes called the analyte. The question tells us that we have a known volume of base. Our titrand with the unknown concentration must have a known exact volume. So in this case, the base is our titrand and should go into the Erlenmeyer flask. This means that the acid should go into the burette. So let's summarise. We know that the titrant with known concentration should go in our burette, while the titrand with an unknown concentration goes in our flask. And there's a range of indicators we can use to find our endpoint. And the keys to a successful titration are a careful setup, dropwise addition, and plenty of swirling.